Okay, so in this section, 6.2, circles, polygons, perimeter, and area, our objectives are to explore the properties of polygons, apply the concepts of similar triangles, and apply the concepts of perimeter and area. We start with our definitions. We see that a circle is defined as the set of all points in a plane that are a certain distance from a fixed center point. So if this is our fixed center point, then the circle itself is a collection of points that are equidistant from that fixed center point. The segment that goes from the center to the circle is called a radius, and a segment whose endpoints are on the circle and passes through the center is called a diameter. Polygons are defined as closed figures. They can have 3 or more straight segments that create their figure. Just to show you that if I have a curved figure with straight figures, this is not a polygon. All of the sides must be straight edges. So where 2 line segments of a polygon intersect gives us a vertex. Let's fix this edge and turn this into a polygon. So where 2 sides of a polygon meet, that gives us a vertex, and then these 2 meet here, and so on. We have all of our vertices. A diagonal of a polygon is a line segment joining 2 non-consecutive vertices. So this is a diagonal because this vertex is adjacent to this one. 1 and 2 are adjacent, but 1 and 3 are not adjacent. So that gives us a diagonal. Diagonals are easy to see in 4-sided polygons, but let's draw a polygon with more sides. So we see that vertex 1 and vertex 2 are adjacent, so if I wanted to draw a diagonal, I would have to draw it to anything except the adjacent ones. The adjacent ones, when we combine them, give us a side. The non-adjacent ones, when we connect them, give us diagonals. Next, we have convex polygons. A convex polygon is one in which all the interior angles measure less than 180 degrees. A property of convex polygons is that every diagonal remains on the inside of the boundary of the polygon. So this is an example of a convex polygon. And then here we see concave polygons. There's a polygon where 1 or more of the interior angles measure greater than 180 degrees, and the property is that the diagonals can pass through the outside of the polygon, the exterior region. So again, consecutive vertices give us a side, and this is consecutive, that's another side, but the non-consecutive, if I attach them, this is a diagonal. And we see that in a concave polygon, the diagonal can pass through the outer region of the polygon, where in a convex polygon, the diagonals will always remain on the inside region of the polygon. The interior angle sum, we can see that a triangle or a polygon with 3 sides has 1 triangle and is equal to 180 degrees. So angle 1 plus angle 2 plus angle 3 equals 180 degrees. But a 4-sided polygon, we can cut that into 2 triangles, and that means that those 2 triangles have 180 degrees each. So 4 sides equals 360 degrees as the sum of interior angles. And we see that with 4 sides, there's 2 triangles and 360 degrees. And then if you had 5 sides, you can cut this into 3 triangles. (180 times 3 triangles) gives us 540 degrees. And we see the list goes on and on. And we can go up to n sides. And that gives us our formula. The number of sides n, number of sides minus 2 times 180 is the sum of interior angles for a polygon with n sides. Skill check number 1. What is the sum of the measure of the interior angles of an octagon? So an octagon has 8 sides. Sum of interior angles is equal to 8 minus 2 times 180, 6 times 180, 1080 degrees is what you get if you add angle 1 to angle 2 to angle 3 to angle 4, 5, 6, 7, and 8. If you add those 8 angles up, they will add up to be 1080 degrees. Next topic, we have similar triangles. Two triangles are similar if the corresponding angles are congruent. Often this is denoted with arcs. We can say these two angles are equal. We can say that these two angles are equal. And once you know that you have two angles from one triangle equal to two angles from the other triangle, then the third angles must be equal. And if that's the case, then if the angles are equal, the sides will be proportional. So if the angles of a triangle are congruent, then the sides will be proportional. And if we call this A, B, and C, and we'll call this X, Y, and Z, we can see that side AB over XY is equal to side BC over YZ, and that is equal to side CA over XZ. So here's an application problem with similar triangles. Suppose a man that is 6 feet tall is standing 20 feet from the base of a tree, and the sun shines on the tree and the man, and it casts a 30-foot shadow as seen in the figure. What the word problem leaves out is that the man's shadow must be lined up with the tip of the tree shadow at this point. Okay, that must be true for this to work. So we have here what's called similar triangles. This angle belongs to both the small triangle you see here, but it also belongs to the large triangle. So since this angle belongs to both triangles and both triangles have a right angle here, we said that if two angles of one triangle are equal to two angles of another, the third angles must be congruent. And we have similar triangles, and that means that the sides of the triangle must be proportional. So the large triangle has a shadow of 30 feet and a height that is unknown. The small triangle, well, if the shadow is 30 feet and the man is standing 20 feet from the tree, then the man's shadow must be 10 feet. And it tells us the man stands 6 feet tall. So now we can write a proportion, and we have to use the corresponding parts of the triangle. So if the base of the little triangle is 10, and I put that over the base of the large triangle, which is 30, I can set that equal to the height of the little triangle, which is 6, over the height of the large triangle, which is 10. And now we can cross multiply and solve the cross product. We get 10x equals 6 times 30 is 180. X is 18. That means that the tree is 18 feet tall. Perimeter of a polygon is the sum of the lengths of the sides of the polygon. So in each of these figures, assume that the distance between the two grid lines, both horizontally and vertically, is 1 unit. What is the perimeter of each figure? So we can look at figure A, and this is a simple trace. We just say it's 1 unit, 2 units, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perimeter equals 12 units. Here we see that this is 2 units long. We see that this side is 3 units long. The base is 2 units. We have 1, we have 1, we have 1. So now we can add these all up. 1 plus 1 is 2, plus 2 is 4, plus 1 is 5, plus 3 is 8, plus 2 is 10. This one is 10 units long, or the perimeter is 10 units. Here we have a triangle that has a height of 1 unit and a base of 2 units. We need to find the length. So this is a right triangle. We'll use the Pythagorean theorem. 1 squared plus 2 squared equals c squared. We always use c for the hypotenuse. So we have the square root of 5 is equal to c. So the perimeter is equal to 1 plus 2, which is 3, plus the square root of 5. 3 plus the square root of 5 gives us about 5.24. Next, we look at area. Area is defined as the number of square units that are required to cover a polygon. So here we can count the squares. 1 square, 2, 3, 4, 5. So 5 units squared is our area. In the second one, we see 1, 2, 3, 4. Area is 4 units squared. And here we see that we have a little less than 1, but this one kind of makes up for it. It looks like the area is about 1 unit squared. We can calculate this using a formula. Area of a triangle is 1/2 the length of the base times the height. We see that the base is 2 and the height is 1. So area is 1/2 times 2, which is 1 times 1. So it is indeed 1 unit squared, as we estimated from the drawing. So here are our formulas. If we have a rectangle, the perimeter is 2 times the length plus 2 times the width. Or you can say perimeter is 2 parentheses length plus width. Both are correct. If we have a rectangle, area is length times width. So if we look at an example here, perimeter is 2 times 2 plus 4. Perimeter is 2 times 6, which is 12. We would say the area is 2 times 8, which is 16 units squared. versus just units for the perimeter. A square has all equal sides, so we're able to simplify the formula. We can say that the perimeter is 4 times s. Instead of having lengths and widths, since all the sides are the same, we use s to represent side. And instead of having length times width in the area, we would say side times side, so we get side squared. So if we have a square with side 3, perimeter would be 4 times 3, which is 12 units. Area would be 3. Let me fix that. Area would be 3 squared, which is 9 units squared. Triangle has a perimeter, which is the sum of the 3 sides, and an area, which is 1/2 base times height. So if we had this as our triangle, the perimeter would be 12, and the area would be 1/2 the base times the height, which is 6 units squared. Now, the base and the height are always connected by a right angle, so that's how we know which 2 sides we need to include in our formula for triangle area. Parallelograms have an area of base times height without the 1/2. So again, you have that right angle here. That's what tells us the 2 sides that we need to. These symbols indicate parallel sides. That tells us we have a parallelogram. And if I had a height here, there would be a right angle saying this is 7 tall and the base is 10 wide. So the area would be base times height is 70 units squared. And the perimeter would be the sum of the sides. And we would just add up the 4 numbers along the sides. In a problem like this, we would need a little bit more information to solve for the sides. But often what's required in a problem like this is to use this right triangle to find one of the parts of the parallelogram. And finally, we have our formula for trapezoid. Again, the perimeter is just adding up all of the sides, but the area is 1/2 the sum of the bases times the height. So if our height were 3 and we had a bottom base of 8 and a top base of 5, area would equal 1/2 5 plus 8 times 3. So this is base 1 plus base 2, the sum of the bases times the height times the 1/2. So area would be 5 plus 8 is 13. Half of 13 is 6.5 times 3. Area would be equal to 19.5 units squared. All right, here are some examples. Finding area. It says Jim wants to build a garden in his backyard. These are 3 different configurations he is considering for the shape of the garden. Determine the area of each of these configurations. Assume that the grid lines are 1 foot apart. So we would just count the grid lines to see how long each side is. So for example A, we see that the length along the base is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 units wide, and then 1, 2, 3, 4 units high. So perimeter would be 24 units, which is in feet here. And area would be 32 feet squared. In example B, we can cut this figure up into 2 pieces, and the area of the top square would be 2 by 2, which is 4. The area of the bottom rectangle is 1, 2, 3, 4, 5 by 3, which is 15. So the area is equal to 19 feet squared. If we wanted to find perimeter, we would just count our way around. Perimeter equals 19 feet as well. And for case C, if we were looking at perimeter, 1, 2, 3, 4, 5 high, 1, 2, 3, 4, 5, 6, 7, 8 along the base, we would use the Pythagorean theorem to find the hypotenuse. So c squared is equal to 5 squared plus 8 squared. C squared is 25 plus 64. C squared is 89. Square root of 89 is 9.43. So if we wanted perimeter, it would be 5 plus 8 plus the 9.43. That would be 22.43 feet. And if we wanted the area, it would be 1/2 the base times the height. The area, half of 8 is 4, times 5 is 20 feet squared. Composite area, again, we can divide these shapes up. I see that because from here to here is 28, that means from here to here must be 28, and the leftover of this 40 must be on this part of the figure. So 40 minus 28 gives us 12. And I see that this part of the rectangle here is 9, which means that we have 9, and then this part is 7. So combined, that's 16. I can say that I have a rectangle here that is 16 by 12, and a second rectangle here that is 9 by 28. Determine the area to be painted, so that means we're talking about area, 16 times 12. 192, and 28 times 9, 252. So part A is 444 square feet. Part B says if a gallon of paint will cover 350 square feet, how many gallons of paint will be needed? 444 divided by 350 is 1.27 square feet. I'm sorry, 1.27 gallons of paint. Skill check number 2. If carpeting costs $2 per square foot and we wish to carpet rooms of the size 12 by 16 and 15 by 20, how much would it cost to carpet these two rooms? So 16 times 12 and 15 times 20. We have 492 square feet times $2 per square foot gives us $984. Example 5, find the area of the parallelogram. So area equals base times height. Area equals 13 times 6. Area equals 78 meters squared. Find the area of a triangle. It says a triangle plot of land has the dimensions shown in the figure. A farmer wishes to fertilize the plot for spring planting. If 1 bag of fertilizer covers 15 square meters, how many bags of fertilizer will be needed? First, we want to find the area. This is the height. This is the base. We said that those numbers are connected by the right angle. Area is 1/2 base times height. Area equals, I'm going to multiply 1/2 by 12 and get 6. So it's 31 times 6, which is 186 meters squared. One bag will cover 15 square meters, so 186 divided by 15 gives me 1 minus the 15, 36. That's 2 times 15 is minus 30. And 4 times 15 gives us 60. So 12.4 bags of fertilizer. Find the area of the trapezoid in the figure. So we have to remember we have two bases. Base 1, base 2, and this is our height. Area is 1/2 the sum of the bases times the height. Area is 1/2, 12 plus 17 times 9. Area is 1/2 times 29 times 9. 0.5 times 29 times 9. And we have area is equal to 130.5 feet squared. Circumference of a circle. So the perimeter of a circle is called circumference because it's not a straight edge. We have a different word for it. And the circumference is defined as 2 times pi times the radius, or the diameter times pi. Circumference equals 2 pi r, or since diameter is equal to 2r, we can say circumference equals pi times d. So we have two different formulas that we can use for circumference. Both are right. So if I had a circle with diameter 10, then the circumference would be equal to 10 pi. Or the circumference would be 10 times 3.14159, and that would make it approximately 31.4159. Area of a circle is defined by the number of square units inside the circle and is calculated using pi r squared. So we see that we can count, but there would be a lot of estimating here with all of these different parts of a square unit. So mathematicians have worked this out, that this gives us the area of the circle. So if I had a circle with diameter equal to 10, I see that I must use the radius. If diameter equals 10, then the radius equals 5, and circle area is equal to pi times 5 squared. Area would be 25 pi. Or if we wanted a decimal answer for that, it would be about 78.54. Example 8, area and circumference of circles. A fish tank has a circular top with a radius of 15 centimeters. Jeff wants to cut a cover for the fish tank out of glass. Find the area and circumference of the cover of the fish tank. So we're only considering the circle up here. We can draw this saying that I'm looking overhead at that circle, which is 15 centimeters. The circumference would be 30 pi centimeters. The area would be 225 pi centimeters squared. So I just used the formulas there. Circumference is pi times d, or you can say circumference is 2 pi r, and area is pi r squared. Skill check number 3, find the area and circumference of a circle with diameter 10 inches. We did this one already. Radius equals 5, so circumference is 10 pi, area is 25 pi. Let's do a second example, find area and circumference of a circle with diameter equal to 16 inches. That means radius is 8 inches. Circumference would be 16 pi inches, and area would be 64 pi inches squared. And then you can enter these into calculators if you needed decimal answers. Example 9, application of area. Consider the size of the lawn of a local park. The park consists of a grassy rectangular area determined by the dimensions of 228 feet by 380 feet, as shown in the image. We need to install circular sprinklers in the park in order to cover the grassy areas for the most complete coverage of park grounds. The sprinkler has a maximum radius of 38 feet, and the sprinklers will be placed in a grid-like pattern as seen in the figure. If we have 15 sprinklers, how much of the grass will not get water? So, our sprinkler has a radius of 38 feet. So we can find the circle area is equal to pi times 38 squared. So the area is 1,444 pi feet squared. That's for one sprinkler. We have 15 sprinklers. So that gives us 21,660 pi feet squared. And let's multiply the pi into that. So we have about 68,047 square feet. This is how much the sprinklers cover. Now we have a rectangular area of all the grass. Area is equal to 228 times 380. $86,640. And if we subtract from that the 68,047 square feet that the sprinklers cover, about 18,593 square feet of grass will not get watered. Okay, so review the video, pause it, rewatch it, take notes, and then move on to the section exercises.